Okay, so at this point in our understanding of cross product and dot product and vectors in general, it might be worth taking a look at a practice problem or a possible problem you might find on a test that applies these concepts. So let's look at this. It asks, find the angle between the longest diagonal PQ of a cube and a diagonal PR of one of its faces. Hint, the calculations will be easier if you use a unit cube in the first octant, with a vertex P at the origin and the edges along the 3 coordinate axes. Okay, so let's go with their recommendation, their hint. And the best thing to do when given a problem is to just draw out a picture. So if I can get a nice sort of coordinate axis up in 3D, it's close, maybe, oops, oh wow, that's not good. One more. There we go. Okay, so we'll label this as the X. We have our Y here, and then we have our Z here, just like you'll see in any of your math classes. And it asks us probably to use a unit cube. And so unit cube, you'll remember, is where every side length is 1. So we'll mark out those points here, and then we'll sort of just draw this in here. And this will come here. This is going to go up. This is going to go up as well. These two will connect. This one's going to go straight up. So I'm hoping this is somewhat able to see sort of the unit cube here. And it's asking us to make vertex P at the origin. And so let's go ahead and do that. This is vertex P at the origin, just like it told us. You know what, this arrow is going to get kind of messy, so I'll put it on this side. And this is P. P is at 0, 0, 0. And we're going to have Q. Q is going to be up here. If we think about it, this is the longest diagonal of the cube, which is what it's sort of asking us for. And that's 1, 1, 1. If you think about it, we're coming 1 in the x direction, 1 in the y direction, 1 in the z direction. And a diagonal PR with one of its faces. So we can really choose any face. We could choose this face here, we could choose this face here, or we could choose this face down here. And I actually don't see a problem with choosing this face down here. I think it's going to be cleanest for the image. And so we'll say that this is PR, or this R here. And this R, it's going to be 1 in the x direction, 1 in the y direction, and 0 in the z direction. And so let's just quickly draw in these two vectors. So this is vector PR. And then here we have, oops, this is going to be a difficult drawing to pull off. This is going to be the longest diagonal. And so let's just start by defining these vectors. First of all, I want to give them simpler names. So instead of calling both of them these PQ, I'm just going to call this A. And so this is the longer diagonal. And in order to calculate a vector, if we want to get these vectors just in terms of the 3 sort of coordinates that they have, we have to take the final point, or the point the vector is pointing to, and then subtract it from the point where the vector is coming from. So we can do that pretty easily. We know it's coming from point Q, which is 1, 1, 1. And we're going to subtract it from point P, which is just 0, 0, 0. This gives us that our vector PQ, or rather A, is just 1, 1, 1. We can do the same thing for PR to calculate that. And we're going to say this is equal to B, just, for simplicity, writing PR is going to get annoying. And we'll take R and we'll subtract it from P. R is just 1, 1, 1, 1, 1, 0. And then we'll subtract from that 0, 0, 0. And this will get us 1, 1, 0. So now the question that it's asking, now that we really have everything defined, we're at the point where we can start looking at what it's asking. And if we read the question, we're essentially trying to find the angle between these two vectors. And our first vector is PQ. Oops, that is a terrible color. PQ, and PR. I don't think I'm going to be able to write on them today. PQ and PR. And so that means that it's referring essentially to this angle here. And we'll call this angle phi. Okay, so how can we calculate phi? Well, as soon as I hear about an angle, and in this case, this angle is between two vectors, the first thing I'm thinking about is cross product and dot product. And if you'll remember, dot product is a bit easier to calculate because cross product requires you to take the determinant of a matrix like this. And because it would be nicer not to have to take that determinant, I think we should try to first start with cross product, and if we're not able to get a viable solution from that, we'll move on to cross product. If neither of those look like they're going to work, then we'll find a different plan. So firstly, cross product. What do we know about cross product and how can we exploit it? Well, first of all, what we're trying to exploit from cross product is the fact that if you have two vectors, let's say you have vector C and you're crossing it with vector B, then the magnitude of this really produces a scalar quantity, which just means a number. It's going to be CB, where these are the vector magnitudes, and then it's going to be times cosine the angle between them if we assume that angle is theta. So in this case, that's going to be giving us the equation AB equals AB cosine theta. Or rather, not theta in this scenario, but phi. And let's exploit that. We have phi in the equation, and we have a lot of things we can calculate. First of all, calculating AB dot product is pretty easy because we have both of these vectors. It's just going to be this 1, 1, 1 vector dot product by this 1, 1, 0 vector. And if you remember how we do dot product, we take each corresponding value of each vector, multiply them together, and then add them all. So it's going to be, we're going to have 1 times 1, 1 times 1, plus, 1 times 1, plus 1 times 0. And this is getting us 2. So now we know this is now 2. It's clear. And so now we can say that 2 equals AB cosine phi. We seem like we're pretty close, but we have to find this, AB. And we can find AB. Remember that if we have A without an arrow on top, it means that it's asking for the magnitude of the vector. And so in this case, that's just going to be the square root of 1 squared plus 1 squared plus 1 squared, or square root of 3. And in this case, it's going to be 1 squared plus 1 squared plus 0. You should probably brush up on this if you're not familiar, and it's going to be square root of 2. So now it looks like we have essentially everything we need. We can make the assertion that 2 is going to be root 3 times root 2. I'm just plugging these in here, just to, oops, that was a terrible circle. Plugging it in here. And that's all going to be times cosine phi. And then we can, from here, get the equation. Cosine phi equals 2 over root 3 root 2. We can simplify this down to 2 root 6 over 6, which is root 6 over 3. So if we sort of delete all of this stuff, all this stuff that we don't need anymore, we get cosine phi is equal to root 6 over 3. And then we could take the inverse of this to get cosine, or to get, rather, root 6 over 3. And there we go. We've solved for phi right there, using dot product. So, if you have any questions about this or are confused about this, you should probably look back at some other lectures about cross product, dot product, vectors, magnitudes, etc. because all of that is going to be really important here because it's all coming together sort of in one problem. Thanks for watching, and I'll see you soon.